right? So I'm going to demonstrate some training on it. One of the unique things of the CS2, because of our unique architecture as well as our overall architecture of the wafer scale cluster, is you can train essentially high resolution images and volumes essentially out of the box without worrying about memory constraints and things like that. So in this release, and the demo I'm going to show you, so we're going to train essentially a 7,000 by 7,000 image on UNet. Now, I think when we last checked, and this has been a while, but or more recently, you can normally on your traditional GPUs, you're looking at orders of 256 or 512 is usually the range of images that people can train out of the box without any specialized code. Whereas on the CS2, we can essentially go with up to 7,000 across 7,000. And to get that started, again, we'll be using the model zoo code. No real code change as such. This is instead of going into the transformers directory, we're going into the CV directory, into the UNet. We're going to be using one of the configs available here, which is going to be the Arial 7168. Just to quickly show you, for those of you who have already downloaded the Model Zoo or cloned it from Model Zoo, the only difference you'll see will be the data directory change I made here. This is just to point to a 7168 aerial image dataset. This dataset is now copied over onto the ALCF system, so it is available if anyone wants to try it later on as well. And just like before, the commands look quite similar. We're going to be running a run.py on the CS2 for weight streaming. The YAML file is taken from there, and the rest are essentially the same. We're specifying a different model directory here, just so it stores the results there, but the rest of it is essentially the same. So since we didn't provide a checkpoint, it's going to initialize a checkpoint and generate it. So it's now beginning the compile process. While this gets going, any questions on any of the large language model features or things we covered earlier today? As you can see, compile was successful. It does tend to take a little longer if you're trying compiling from scratch, but we did a similar version earlier, so it probably just recompiled from that. And similar to before, you can again use CSETL to look at the available jobs and what's running. As you can see, we're running it on one CS2. Yeah, one thing to keep in mind is most of the things we show today are not really specific to a type of model. All these features essentially do work across model families and such. There's a question from Bill. Does the compiler place multiple instances of a model on a CS2 if they will fit? No, since we're loading the models essentially at a high level, at least at a layer by layer level, it doesn't load multiple instances. It will increase based on the size of the layers, it'll either stack them accordingly to make sure you're getting the full utilization of the wafer. So at any point, only one model is running on a single wafer, or one portion of a model is running on a single wafer. But no, we don't do essentially like a time slice on the wafer between two models. I hope I answered your question, Bill. one of the interesting things. Yeah, yes. In terms of full wafer utilization, yes. Even if the models, unless they're extremely small, in which case then, which in that case you may not get the full best utilization. But currently, if any reasonably large size model, and especially what we see in the large language models or in the CV space, you would get good utilization of the wafer. Varuni asks, any recommendations for improving the chip utilization? So given the idea, one of the things we focus heavily on is trying to make this as ease of use as possible. And one big component of that is to trying to make sure the user gets the best performance out of the box, so they don't need to do tricks or no special things to make sure they get the best performance. One thing to definitely to keep in mind though is that if you're especially when you're using your own custom data set and writing your own data loaders, it is very important to make sure the data loaders are optimal, because if the data loader is slow, we are not feeding enough data essentially to the wafer, and so the wafer is not being utilized fully. So that's often a constraint we see people make, where they don't take the time to optimize the data loader. The website and our docs do go over some of the best practices, and we have again examples in the models on the existing data loaders that we use for this that tend to be good templates to build further on top of this. Saugad asks, is the pipeline model currently not supported for UNet? I tried earlier and yes. So UNet is now, especially for these larger images, works only in the weight streaming mode today.
Yeah, and I'll jump in and reiterate again. If anyone's not from ANL is not yet on the Slack, we'd love to send you an invitation, go deeper on, either current troubles you're facing or kind of new requests for what you'd like in the future, or hear about the continued work you like to do, and maybe we can intercept you once you're ready to do that work with our software upgrades release by release.
John asks, how do we get added to the Slack channel? John, I think if you send out an email to developer@cerebras.net, we'd be able to follow up with you, or I think Morley might be able to help you get on it as well.
Hey, John, if you're at ANL right now, you can just message me your email in a Zoom direct message, or, oh, Murder's got you. Great.
The Cerebras community Slack channel. No, we have a direct Slack channel between Cerebras and ANL, where users of the system can raise requests, or if they're running into challenges, or we often collaborate on things. We do have like public channels on Discord and Discourse where people can reach out if they're just generally curious about what the community is working on. We see a lot of interesting activity there where people are coming up with new, unique ways of using the models to do very interesting things. Mostly, I think there are a few more requests to be added to the Slack channel, or Richard, who is making note of those.
Yeah, we'll track them all down. Thanks, Vishal.
Yeah, thank you. So as we can see here, we just finished transferring the weights. We'll soon be seeing some losses. I'm going to spin up the tensor board in the meantime as well. So as you can see here, that went by quite quickly for even a 7K by 7K model. Saves the checkpoint and it's completed. It's pretty quick for such a, even the 7K model. And then it took a final checkpoint and it has essentially completed the training. Trying to see if I can get it on TensorBoard here. There are some of the old runs. Oh, I see the problem. Sorry, the TensorBoard is pointing to the wrong directory. So now you can see the UNet. As you can see, again, it's a small run, so it hasn't actually gotten much progress, and I haven't fine-tuned anything. I haven't tuned the hyperparameters here to get the best convergence. This was just to show that you can run significantly large models out of the box, even in vision on the Cerebrus systems.